Bonjour, hello. I'm Isabelle Guyon, professor at Université Paris-Saclay. I will be talking to you today about the Human AI project for democratizing artificial intelligence. This is a project of the Laboratoire de Recherche en Informatique at Université Paris-Saclay and INRIA, funded by ANR and the Paris region in collaboration with Michel Sebag, Marc Schonauer, Anne-Catherine Letournel, Laurent Daré, François Land, Jianqing Yu, Adrien Pavao, and Haotse Sun. On one hand, the rapid progress made by artificial intelligence over the past few years has been accompanied with a variety of misuses, ranging from autonomous weapons, social manipulation, invasion of privacy and leakage of personal data, to unethical and irresponsible uses. On the other hand, AI is powering many applications beneficial to society, including epidemiology and medicine, sociology and education, ecology and climate science, assistive technologies, and knowledge and communication. We believe that a solution to promote good uses of AI and counteract the bad uses is to democratize AI as much as possible by empowering as many people as possible to have AI. To that end, we want to enter a virtuous circle, starting by simplifying AI tools, powering an infrastructure facilitating crowdsourcing problems with AI for good objectives, and fostering growth with the collection of and distribution of good data rather than merely manipulating big data. This will in turn empower practitioners and the public at large to close the loop and feed data into a new generation of powerful but easy to use AI tools. To advance towards empowering the public with AI tools, we have set to work on the automation of machine learning, which means creating programs that can learn from examples without human intervention whatsoever. To push research in automated machine learning and advanced in many important application domains, we are developing a new generation of AI competition and benchmark platforms, building on top of experience we have with the very successful Codada platform. Specifically, previous competitions will be turned into application templates. Finally, to promote the collection and dissemination of good data, we have set to work on developing guidelines for data and benchmarks with a committee of experts to promote best practices based on past experience we have in organizing many competitions and benchmarks. Our effort to accelerate the democratization of AI will take place at three levels: education, research, and applications. Let us start with the core of our activity, namely research, which will fuel the other two levels with innovation. Our research effort in automated machine learning is supported by the Codada project, an open source software project started at Microsoft, and of which Université Paris-Saclay is now community lead of the Codada competition branch, while Stanford University is leading the Codada worksheet branch. We have collaborators from around the world, including Percy Liang, Evelyn Viegas, who are co-founders, Jen Zhu, Tyler Thomas, Sergio Escalera, Weiwei Tu, Eric Carmichael, Anne-Catherine Letournel, and Adrien Pavao. Our first effort towards the democratization of AI has been the AutoML Challenge series, taking place between 2015 and 2018, sponsored by Microsoft and 4Paradigm. One of the hallmarks of AutoML challenges is that their evaluation is performed via complete blind testing, both for training and testing. The participants submit their code, which is evaluated on the Codada platform using datasets that are not visible from the outside. AAD Freiburg produced a Python-based tool called AutoSKlearn that not only won many of the phases of the challenge, but became a standard in the field of automated machine learning for tabular data. AutoSKlearn is a wrapper around the scikit-learn library that does both model and hyperparameter selection. And my PhD student Lish and Sung both placed well in the challenge and made an in-depth analysis in her thesis, identifying the need for improving on meta-learning techniques, for which she proposed an algorithm called active metal for active meta-learning. We went on to organize a series of challenges on automated deep learning called AutoDL, sponsored by Google and for Paradigm. We progressively ramped up difficulties by introducing various modalities, image, video, text, speech, and then a little bit of everything. The code of the winners was open sourced, and the analysis, which was recently published, will be an important part of the thesis of Xiangying Liu. As part of the HUMANIA project, we keep pushing the automation of machine learning with a new series of challenges on automated machine learning, including AutoSeries, AutoGraph, MetaLearn, NAS, and AutoRL. The highlights are that the code of the winners is open sourced. We have a new design of the interface enforcing modularity of the solutions and automated workflow, which will lend solutions to be more interpretable and allow us to make more systematic comparisons. We are putting more emphasis on meta-learning, which means that machines can continuously improve themselves by being exposed to more tasks. And we are working towards theoretical guarantees of performance in the setting of anytime and any resource learning. This work will be part of the PhD thesis of a new doctoral student funded by ANR, Hao-Se Sun. And this work is made possible by the Codalab platform, which over the years has grown both in complexity and usage, reaching now 50,000 users and 1,000 organized challenges, 400 of which were made in the past year only. With Codalab, past challenges will be turned into templates to create new challenges and crowdsource new applications. The thesis of Adrien Pavao will be dedicated to methodology of challenge organization. A new development of the Codalab project is the creation of a benchmark platform called CodaBench, a first version of which will be released by the end of the year. With CodaBench, it will be possible to create benchmarks consisting either of a set of reference tasks against which many different algorithms can be compared, or a set of reference algorithms to which new tasks can be submitted. The highlights of that project, with emphasis on data, are that it is supported by the EITL's COMET project and will have a first medical application in cancer research. We are leading a NeurIPS committee of data and benchmark and planning a special issue of Data in Machine Learning Research Journal. We are also working in conjunction on synthetic data generation with theoretical guarantees of privacy or confidentiality, and all this work will be part of the thesis of Adrien Pavao. Let us now move on to the application part of this project. The AutoML research effort and the Codalab project have been inspiring industry challenges. They feature blind testing with code submission like the AutoML challenges. Solutions of previous challenges made part of starting kits can inspire the participants. Winner solutions will be made part of CodaBench to enable new applications. And to facilitate the creation of new challenges, Adrien Pavao is working towards rationalizing the methodology of challenge design for his PhD. As an example, we have been collaborating with RTE France to organize a 2 million prize challenge on power transportation as part of the European project C4C. Research on power networks led to the PhD thesis of Benjamin Donneau in 2018. We have continued working on power transportation with a series of challenges in reinforcement learning called Learning to Run a Power Network, or L2RPN, whose goal is to learn policies to better optimize electricity transportation while keeping equipment and persons in security. Our PhD student Balthazar Donneau was involved in the design of the challenge and the gamification of the problem. We started in 2019 with a toy power grid example of 14 nodes for the conference IJCNN 2019. And then we scaled up the challenge to 118 nodes, and this is an ongoing challenge targeting the NeurIPS 2020 conference. The key enabling technology are Codalab competition bundles, which are zip files containing all the necessary ingredients to create a challenge, including configuration files, documentation files, programs to run and score the code of the participants, data, and sample submissions. Such competition bundles allow us to create application templates. We are working towards creating a repository of such templates. Users will be able to download and edit a template suiting their needs. Then the modified bundle can be re-uploaded to the platform. And ta-da! A new competition or benchmark will be created. You see on this example a competition that was created by a student of Mark Schonauer, Harry Rakotoa Harrison, on the problem of recognizing the malaria parasite from microscopy samples, a challenge promoted by the AI for Good Foundation and the Data Science Africa Conference. We attach a lot of importance to the dissemination of results of the challenge, so we organize workshops at major conferences where winners can present their solutions. We also have a Springer book series on challenges in machine learning where longer papers can be published. And last but not least, human AI in education. We have worked towards a progressive curriculum in data science and AI with emphasis on probability optimization and modeling from the first year university to the master level. We will be teaching this year a new class in the AI Informatics Master of Paris-Saclay on automated machine learning and how to squash the problem of neural architecture search and hyperparameter selection. We have been teaching already in the past few years a class on how to create challenges starting from templates. Via this medium, students learn how to tackle end-to-end data science applications, from data formatting to prototyping solutions. They work in teams of 6 to produce a challenge, pretty much like a mini startup launching a product. And the result of their work is indeed a mini product, since the challenges they create are then used in a class of L2 students as their data science projects. In that class, students learn while having fun how to use Python, scikit-learn, GitHub, and other data science tools. And since last year, we are teaching an L1 class of Introduction to Data Science. We teach them that a data analysis is like a chain, which is not stronger than its weakest link, and we sensitize them to not only the problem of variance in data and in modeling, which may lead to the problem of overfitting, but also to problems related to bias. What do we mean by bias? All sorts of biases. Bias linked to prejudice and discrimination, and also all kinds of biases, sample bias, drift, confounding, data leakage, etc. And with that, we have covered the outline of our project, and we hope that you will be interested in joining us entering the virtuous cycle of democratizing AI. Thank you for your attention.